Okay, this lesson is going to look at properties of real numbers, and the objective is to identify and use these properties of real numbers. So we know that two expressions are said to be equal if they have the same value for all values of the variables. So we've got the commutative property of addition and multiplication. We're changing the order of it's important to know that changing the order of the addends does not change the sum. It doesn't matter, we talked about this a little bit in class yesterday. If I say 7 plus 2 or if I say 2 plus 7, I'm still getting 9. Same thing is true of 2 times 5 is 10, 5 times 2 is 10. Changing the order does not change the sum or the product. Now with subtraction, we talked about yesterday, it does change it. So you got to be really careful with that. That's why it says commutative property is for addition and multiplication. So an algebraic example is a plus b is equal to b plus a times b is equal to b times a, and I already gave you the numeric example. Remember, algebraic is involving letters, numeric is numbers only. Algebraic can be numbers and letters. Okay, the associative property of addition and multiplication says that changing the grouping of the addends does not change the sum. So changing the way that I group them. Let's go back here to the commutative. Commutative is changing the order. Associative is changing the grouping. Grouping, it has to do with parentheses. Okay, for some reason my connection is not working very well this morning. This is true for addition and multiplication once again. The order that I group them in doesn't change the actual sum or the actual product. So I've got the algebraic example written up here for you. Let's look at a numeric example. Let's say I do 3 plus 2 outside of parentheses plus 1. And what I'm saying is that is equal to the changing of the grouping where I put 2 plus 1 together. So let's look at it. Order of operations tells me to do the parentheses first, so I would have 5 plus 1. That should be equal to 3 plus 3. We know 5 plus 1 is 6, 3 plus 3 is 6, and therefore they are equal. Same is true with multiplication. I'll write a little bit smaller over here. Let's just do the same numbers. 3 times 2 times 1 should be equal to 3 times 2 times 1. So order of operations, I'm going to do the 6 first times 1. Over here I'm going to do the 2 times 1 first and get 2. 6 times 1 is 6. 3 times 2 is 6. So they are equivalent. The identity property of addition and multiplication says that the sum of any real number and 0 is going to be the original number. The product of any real number and 1 is always the original number. So with addition, we have a plus 0 equals a. With multiplication, a times 1 equals a. I feel like the identity properties are probably the easiest because the identity property tells me that what I started with is what I'm going to end with. It's like looking in the mirror or looking at your identification. If you get pulled over, hopefully none of you get pulled over ever, but if you do, the officer asks to see your identification. What's he asking for? Your driver's license. Why does he want your driver's license? Because it's a picture of you. It looks like you. You start with A, you end with A. He's looking at you, your driver's license, your identification looks like you. So that's what I always think of with the identity property. The 0 property of multiplication is pretty easy too. We know that anything times 0 is always 0. And the multiplication of -1, that property tells us that anytime I multiply by -1, I just end up with the opposite of what I started with. So 5 times -1, I started with a positive 5. I end with the opposite of that, which is -5. If I look at -5 times a -1, a negative times a negative is a positive. So I started with negative, end with positive, end up with the opposite of what I started with. So it says name the property that is illustrated. Well, this is nothing more than the 0 property of multiplication. Here we changed the grouping. We went from grouping y and 2.5 to grouping 2.5 and 28. So that is the associative property. And then this is the property where when we add something, we end up with exactly what we started with. So what is that? It's the identity property. So the movie ticket costs $7.75 and a drink costs $2.40. Popcorn costs $1.25. What is the total cost for a ticket, a drink, and popcorn? And I don't want you to use calculators. I want you to use mental math. So go ahead and pause the video and see what you can come up with. You might think, how is this relevant to what we were talking about? We've been talking about properties. Well, we can use properties sometimes to help us solve problems when we're using mental math. And what I mean by that is I'm going to go ahead and group those two together. Why would I want to group $7.75 and $1.25 together rather than $7.75 and $2.40? Well, we know quarters makes it kind of easy to go ahead and add, right? This 75 cents and this extra quarter here are going to add up to $1. So I've got 7, 8, and then that extra dollar making $9. Then I can add $2.40 really easily. 9 plus $2.40 is $11.40. Did not use a calculator. I did that totally in my head. That would have been a lot more difficult if I would have grouped, say, this together first. 25 cents and 40 cents is 65 cents, and I'm trying to add 75 more cents. Makes a whole lot more sense to group cents. Makes more sense. Which sense am I talking about? Makes more sense to group the $7.75 and the $1.25 together. Okay, so let's compute these, or not compute them, I'm sorry. We are going to simplify these by writing an equivalent expression. Okay, so right now we can see that we've got a number times a variable. So what I'm going to do is I'm going to regroup. Instead of grouping the 3 and the n together, I want to group the 5 and the 3 together, then times it by n. And I know that I can change the grouping according to the associative property of multiplication. So now this is a little bit easier to compute. 5 times 3 is 15, and then I have 15n. Okay, same thing here. I want to change my grouping around so that I have the 4 and the 8 together in a set of parentheses, and then add the 7b outside of here. Why would I want to do that? Well, these are like terms. They don't have a variable. This is an unlike term because it has included a variable, so I want to keep it by itself. So we can go ahead and say, what is 4 plus 8? Well, that is nothing more than 12. So now I have 12 plus 7b is an equivalent expression. Okay, let's look at the 6xy all divided by y. Well, we know that we can change the grouping a little bit. I'm just going to rewrite this as 6 times x times y over 1 times y. Didn't change anything. The identity property tells me that I started with exactly what I ended with, and I want to do that because now that's going to allow me to kind of break it up a little bit. I want to put this 6x over 1, and then I want to times that by y over y. So I still have the same thing. I just changed the grouping a little bit, the way that I'm looking at these fractions. And now we know that y over y, anytime I have the same thing on top and bottom, that's nothing more than 1. This can be simplified to just 6x. 6x times 1, back to the identity property, just leaves me with 6x. And that is all I have for that lesson today.